So here's another interesting electronics experiment. What I have here is two different ways of doing the same thing. In the back is a circuit that will take two LEDs and turn them on and off, kind of like a railroad flashing signal. And then over here in the back is my Raspberry Pi. Now I've actually got this Raspberry Pi set up doing about three different things. So what you want to do is pay attention to just the two red LEDs over here, kind of on the right hand side. But I was reading some stuff a few days ago where, for lack of a better word, I'll call a classic electronics guy was kind of talking down about how you can do electronics projects easier with digital methods than you can with analog methods, and it's true. And it's sort of this thing where, while real electronics guys do it old school. I'm not sure I agree with that, but anyway, here's a demonstration of the two different methods, that is analog and digital. Okay, so what I've got here is, with the analog circuit, I've got a circuit where I can put in three different capacitors. This one is 10 microfarads, this one is 47 microfarads, and then this one on the far right hand side is 100 microfarads. And as I switch those in, you'll see that the time period for the LED to stay on gets longer. And do the same thing over here with the Raspberry Pi, except what I do instead of changing capacitors is I simply change the sleep command in the Python program, which controls how long the LED stays on. Okay, so let's run this thing. Okay, so here's the Raspberry Pi way of doing it. So all I've got is a simple Python program that takes two GPIO pins and sets them as outputs and sets them to high for half a second. And now I can turn on the classic circuit in the back. And you can see they kind of flash back and forth at the same speed. Okay, so that's cool. Okay, so now I'm going to turn off the circuit in the back, and I'm going to do a Control-C on the Raspberry Pi program to stop it. So now I'm going to pull out the capacitor on the classic circuit, the 10 microfarad, and I'm going to plug in the 47 microfarad capacitor, and that's going to make it run a little bit slower. And then I'm going to come over here to the Raspberry Pi Python program, and I'm going to change the sleep command from 0.5 seconds of sleep to 2.5 seconds of sleep. Okay? And then save that, and then come over to the terminal. Run it again. Okay, and you can see the Raspberry Pi blinking at a rate of 2.5 seconds. And I'll turn on the classic circuit in the back. Okay, and they're not synchronized, because that's pretty hard to do. But you can see they're kind of going back and forth at the same speed. Okay, so now what I'm going to do, I'll turn off this circuit, and I'm going to pull out the 47 microfarad capacitor, and I'm going to put in a 100 microfarad capacitor. Then I'm going to stop the program over here that controls the Raspberry Pi. And then I'm going to come to that sleep command, and I'm going to input 4.5 seconds, which is about right. It turns out that the analog circuit, the time duration for each light is not exactly the same. That is, it's asymmetric. But of course, running it with a command like this makes it either perfectly symmetric or as asymmetric as you want. Okay, now come over here to the terminal. Do an edit paste to launch it. Okay, so here's the Raspberry Pi turning on the LED for 4.5 seconds, and now we'll turn on the analog circuit. Okay, so you can see they're running at, you know, sort of similar speeds. So it's just interesting to me, you know, is it cheating to control a circuit with a computer and software? You know, and is it, I don't know, somehow better to do it with an analog circuit? I don't know. The old school guys say that, you know, real electronics guys do stuff old school analog, and you know, those darn kids these days do it the easy way. I don't know. I kind of like the computer way of doing it. Anyway, here you go. 2 ways of doing the same thing. Railroad crossing LEDs.